Hello and welcome to Fundamentals of Cybersecurity, CSCI150N. I'm Peter Keurig, and this is Chapter 11, Authentication and Remote Access. In this chapter, you will learn how to identify the differences among users, groups, and role management, implement password and domain password policies, describe methods of account management, describe methods of access management, discuss the methods and protocols for remote access to networks, identify authentication, authorization, and accounting protocols, explain authentication methods and security implications in their use, implement virtual private networks, and describe Internet protocol security. So the outline for this lecture is going to be user groups and role management, password policies, single sign-on, security controls and permissions, preventing data loss or theft, the remote access process, and remote access methods. User group and role management. User applies to any person accessing a computer system, generally the lowest level addressed by privilege management and the most common area for addressing access, rights, and capabilities. Group is a collection of users with some common criteria, such as a need for access to a particular data set or a group of applications. Role is usually synonymous with the job or a set of functions that are performed by a user or a group. Typically, users are, as stated, specific individuals who are employed or are granted access by the organization you work for. And groups, it could be, for example, you could have a group that is all people who work in accounting, and another group that's all people who work in IT. And you could have groups for specific rights, such as elevated rights to your privilege, such as elevated rights to your network, or maybe access to a particular application that you have locked down. And then role could be based upon the roles of the people. So you could have, within your IT department, you could have roles such as system administrators or database administrators or help desk, things of that sort. So you could have the entire group as your IT department, and then you got multiple roles underneath that group. So password policies. Typically speaking, in most organizations, usernames and passwords are used to grant people access to the network and the resources that are on the network. And a good example of that is here at NCC. Your email, you have your Blackboard and all that. They use username and passwords. To help users select good passwords, and you need to have policies in place that dictate what a good password should be, how difficult should it be to guess, and so forth. So, for example, a good password policy might require that there is 15 characters in the word, and you have to have at least 2 uppercase characters, at least 2 lowercase characters, maybe 2 numbers, and then 2 special characters, such as, like, say, question mark and a $sign, or something of that sort. And then, with a good password policy, you would also do restrictions on how often that password could be reused. So maybe you set it so that that password can't be used for 24 times. You have to change it 24 different times before that same password can be used again. So maybe if you, let's say, require them to change it every month, it'll be 2 years before they can reuse the same password they previously had. And that kind of covers the duration I was just talking about. So you can have it be as minimum as 1 day that a password is good for, all the way up to infinity, depending on what your organization sees is best. Usually 90 days is what's best for passwords. Anything more than that, you run the risk of people figuring out what somebody's password is. Anything less than that, and your user is going to have a hard time remembering their passwords. You're going to do a lot of password resets. Protection of passwords. Train your users, don't write it down, and don't have easy to guess passwords, such as their favorite sports teams or things of that sort. Something where if somebody did enough homework on Facebook, they wouldn't be able to guess. Also, common phrases, common sayings, like, let's say, Boston Strong or something of that sort, can be picked up easily too. Then consequences associated with violation of or non-compliance with the policy. Well, first off, if you implement the policy correctly, it's very hard for them to not have to change their password every 90 days if the system requires them to. And if the system doesn't let them reuse the same password, every time they put in the same one trying to change it, it's going to come back as saying, no, you can't use that one. If need be, you can put consequences in place for it, especially for weak passwords. If you work for an organization that maybe does random password tests where they try accounts and they try to brute force the account with a rainbow table of passwords, and you find somebody has let's say password 123 as their password, then you can have consequences in place for them picking such a weak password. So any policy you put into place, be it password policy or acceptable use policy on your network, you need to have consequences that can back up those policies, so people will follow the policies and not just brush it off thinking it's nothing required. So domain passwords versus local passwords. Local password, let's say you set up a local account on a computer in the lab at NCC, that would be the only computer you'd be able to log into. On a domain, you would, for example, on a Microsoft domain, you enter in a username, create a user account on that domain. That username and password is good on any computer that's attached to that domain and uses it for authentication. So I'll tell you, when it comes to password management, it's a lot easier with working with Active Directory or with a domain password than it is for local individualized accounts, mostly because you can enforce it from one centralized interface, which is the Active Directory interface. Otherwise, you are chasing down individual workstations and need to change passwords on them, especially if you're going to have, let's say, a password time or expiration. If a person's password expires and they're on multiple machines and it's not a domain machine, they have to go around from machine to machine on all the ones they've had accounts on and change them individually, as opposed to with a domain password, they change it once and it's good across all the systems. But you'll find as you work with Active Directory, it's a lot easier to enforce password history, the maximum password age, the minimum password age, the minimum password length, and so forth. Complexity requirements. You can get pretty ingrained with a group policy on Active Directory. So single sign-on is both a blessing and a curse. It's a blessing in the sense that you can allow users to set a single username and password across all the different multiple systems you may have on your network. So you could, for example, synchronize Unix accounts, database accounts on various database servers such as Microsoft Server, MySQL, Oracle, things of that sort, along with email servers and Linux or Unix or other systems as well. So you basically, once they change the password once, it changes it for all the systems, and it gets when they sign in once, it lets them in to all the systems. A good example of that is the single sign-on that NCC uses for their email and Blackboard and the SIS. That's all done, so you just change your username and password once, and it's changed across all your systems. Now, the downside to that is once somebody gets a hold of a person's username and password, they now have access to all those systems. So the convenience you provide the users with single sign-on also becomes a disadvantage if that user's credentials are stolen or compromised in any way. So some things that you can do to make single sign-on a little more secure for your users is, first off, time of day restrictions. You can make it so that certain times of day are the only times that those accounts can be logged into, and all other times the account is locked and are accessible. A good example is a company I worked for, where outside of certain people who were in the IT department, such as myself, most users could only access their accounts from 6 a.m. in the morning to 6 p.m. in the evening. And if they try to get in after hours, they had to call us. They had to call whoever the on-duty system administrator was to have after-hour access. So at the very least, we knew somebody was accessing the system. So it cuts down the window of when somebody who's trying to brute force or get into an account without authorization. It cuts down to when they can do it. So if it's down to normal business hours, you're more likely to have somebody catch that there's something wrong going on with a person's account. Then there's tokens. This is an example on the slide of a token where every minute the number on there changes, and it's synchronized with a server on your network and synchronized to the person's specific account. So only the token and the server know what the next number should be. So every minute that number changes, and when a person goes to log in and they put in a username and password or username and PIN, it then asks for whatever the value is in the token, and if it matches what the server is expecting the number to be, then that person would have access at that time. The only problem I've ever seen with one of these is obviously if the token is lost, you have to get a new token. But unless the person who finds this knows the other person's username and password, it doesn't mean anything to them. It's just a number that changes every minute, and it's completely random. Second disadvantage to it is that sometimes they do get out of sync if there's a problem or defect with the token. And the result is that until you get a new token and you get it resynchronized, the user can't get in. And then account and password expiration. So you're narrowing down, let's say you're doing from 6 a.m. to 6 p.m., you're narrowing down when a potential attacker can attack the account. And by expiring usernames and passwords, let's say every 90 days, you're narrowing down how long they have to try to brute force or guess the password. The longer it takes, the shorter window span you give them for trying to figure out the password, the better and more secure your network will be. The reality is that we share systems these days. It's no longer a single computer sitting in a single location with a single user, and nobody can access the data that's on that computer. Be it a networked system or just a system that's being shared amongst multiple employees that's a standalone, you're going to have a need for multiple users to access it. So with that, you need permissions, and you don't want to give everybody full permission on a system because you don't want someone to start randomly adding their own software to it, downloading and installing games or other applications that could potentially expose your system to or things of that sort. You don't want everybody who has access to the system to necessarily be reading all the data that's stored there either. So it comes down to permissions, and the Windows operating system uses the concept of permission and rights to control access to files and folders, as well as information resources and tools such as printers. When using the NTFS file system, which is pretty much what we use these days, users and groups can be granted permission to perform certain tasks as they relate to the files, folders, and registry keys. So you can even restrict what programs people can run, even though they might be able to see the icon. They might try to run it, and it might say, nope, you can't, because the registry key for that particular application, they don't have permission to run it. The Windows operating system also uses user rights or privileges to determine what actions a user or group is allowed to perform or access. The list of rights is quite extensive, but a few of the examples are log on locally. So instead of doing accessing a machine, you can an example is log on locally, so users and groups can attempt to log on to local system itself as opposed to using a domain account. Access this computer from the network. Users can attempt to access the computer through a network connection, for example, remote desktop. And then manage auditing and security logs, so user groups can view, modify, and delete auditing or security log information. Probably not something you want to give everybody the rights to do. The Windows operating system also uses user rights or privileges to determine what actions a user or group is allowed to perform or access. The list of rights is quite extensive, but a few of the examples are, an example is log on locally, so users and groups can attempt to log on to local system itself as opposed to using a domain account. Access this computer from the network. Users can attempt to access the computer through a network connection, for example, remote desktop. And then manage auditing and security logs, so user groups can view, modify, and delete auditing or security log information. Probably not something you want to give everybody the rights to do. So we're talking about users' rights and privileges, and so that leads us to the next thing, which is access control lists. The term access control list, or ACL, is used in more than one manner when it comes to the field of computer security. When discussing routers and firewalls, an ACL is a set of rules used to control traffic flow into or out of an interface or network. When discussing system resources such as Windows, files, and folders, an ACL lists permissions attached to an object, who is allowed to view it, who's allowed to modify it, who can move a file to a different location, or delete it altogether. So access control lists limit what the user can and can't do. or grant access to what a person can and can't do. But there are different schools of thoughts that govern how access control lists are used. The first one that we want to talk about is mandatory access control. So mandatory access control is the process of controlling access to information based on the sensitivity of that information and whether or not the user is operating at the appropriate sensitivity level and has the authority to access that information. So under mandatory access control system, each piece of information in every system resource source, such as files, devices, networks, and so on, is labeled with its sensitivity level. Such as, here they use public and engineering private and Jones secret, but for government circles it would be unclassified, confidential, secret, and top secret. Users are assigned a clearance level that sets the upper boundary of the information and devices that they are allowed to access. So for example, if you have a secret clearance in the government, you cannot access top secret information. You can access lower than secret, so you can access the unclassified, you can access the confidential, you can access secret, but you cannot access top secret. So that's what they're saying here. So likewise, not only can that person with a secret clearance not read the top secret, but just the opposite. You can take that secret piece of information, a secret email, let's say, and you can have that secret email stored on a secret level email server, or you could have it saved on a top secret level mail server. But you can never, or you should never, store it on an unclassified or confidential level, because their security their clearance level is at a lower level than the classification of that document or email. So you can have access up to the level that you have security clearance of, and the file or the resource that you have can be stored at the level that its sensitivity is or higher, but never lower. Role-based access controls are pretty straightforward. It's access that is granted based upon the role that you serve within the organization. So system administrators, database administrators, power users, typical users, things of that sort. Whatever role you play, your permissions are based strictly on that. This makes it a lot easier when you set up your security ACLs based upon roles, because you can just basically define all system administrators have these access to these resources, instead of trying to do individual resources for individual system administrators and so forth. You don't have to micromanage individual users. You manage the whole group as a whole. So what you'll see is as you develop role-based access control lists, that it starts to mimic the structure of your organization. So if, for example, your organization has an HR department, it has a sales department, has an IT department, and maybe a manufacturing department. Let's focus in on IT. So now you've got roles under IT. You have system administrators, you have database administrators, you have help desk, and then you might break it down to roles underneath those. So you have your database administrators, and then you have your backup database administrators, you have your senior database administrators, things of that sort. So you as you start to build the role access control, you'll see that you start to develop new groups. Depending on which operating system you're using or what database system you're using, will depend on exactly how you build those structures. But nonetheless, you'll see that you can get more granular based upon the role, as opposed to having to manually modify each individual user. And then instead, you just assign the users to the group or the role within your access control list. Some other ways to manage permissions and access and privileges are rule-based access controls. It's yet another method for managing access and privileges, and in this method, access is either allowed or denied based on a set of rules. So, for example, you could have a rule in place saying if you try to access a resource at 12 o'clock at night, and users can only use system from 6 a.m. to 6 p.m., and administrators can use until use it 24 hours, depending on which rule or which group they fall under. The rule will affect them specifically. So if they're a general user or they don't fall into the specific 24-hour users, the rule will say, hey, no, doesn't matter what or who you are not accessing this during this time period. Then there's attribute-based access control. It's a new access control schema based on the use of attributes associated with an identity. These can use any type of attribute, resource attributes, user attributes, environmental attributes, and so on, such as location, time, activity being requested, and user credentials. So, for example, if you might put in, let's say, an attribute-based access control that says if you are traveling outside the United States, you cannot access your file share or database, so that if somebody takes a work laptop and tries to VPN in, and they have a IP address from an external country outside of the United States, they can't access your core information. So if for some reason that laptop was stolen while it was outside the country, some foreign national wouldn't be able to access the controlled information within your organization. Then there's account expiration. Kind of talked about this before. Most modern operating systems allow administrators to specify the length of time that an account is valid for and expires. For these accounts, the administrators can specify an expiration date, and when that date is reached, the account automatically becomes locked. It can't be logged in without the administrator intervening and either extending the account or so forth. So I've seen this used in a lot of places, so that annually or maybe once a quarter, depending on the policy within the organization, accounts expire and they have to be rejustified, or they have to be validated by the user's supervisor or manager in order to be sure that the person has a continuing need to have access to that system or that network. In many attacks today, hackers are after intellectual property, business plans, competitive intelligence, personnel information, credit card numbers, client records, or other information that they can sell or trade or manipulate for some kind of profit. This has created a whole new industry of technical solutions labeled data loss prevention, or DLP. It is assumed that a hacker has assumed the identity of an authorized user, and DLP solutions exist to prevent the exfiltration of data regardless of the access control restrictions. DLP solutions come in many forms, and each of these solutions are strengths and weaknesses. The best solution is a combination of security elements, some to secure data in storage, such as encryption, and some in the form of monitoring, such as proxy devices and screening emails, and even NetFlow analytics to identify bulk data transfers that have not been authorized. Data loss prevention can be not only prevent bad guys from accidentally losing your data, it also prevents people from within your network who might accidentally do something from sending out information. So, for example, you can buy a product that works with your mail server. Let's you say Microsoft Exchange, and it searches for social security numbers or credit card numbers. And so, if somebody tries to email a social security number or file with social security numbers in it or credit card numbers in it, it'll detect before the mail leaves the system and block that email from being sent and send a notification to the user that you are sending something that has protected information in it. And either validate that, have the person verify that that is what they want to do, that it wasn't an accidental thing, or block them altogether and send a notification maybe to their supervisor, depending on specifically what it is that's trying to be sent and who's trying to send it. But regardless, sometimes it's not intentional. We see it all the time where somebody will email out PHI, personal healthcare information, or send out what they call PII, personally identifiable information. It could be people's names, addresses, social security numbers, home phone numbers, things of that sort. Nobody meant anything malicious by it. They didn't think about it. They sent it unencrypted or whatever, and data loss prevention could prevent that. So what makes our network so vulnerable these days is that it's not that we want people to access data and information from where they're sitting on their own computer. It's because we want to access everything remotely. We've become a global world where we want to be able to access information on the other side of the world when we want it and when we need it. So because of that, there's different types of protocols and capabilities for negotiating privileges and granting access to information on various systems. So the process of connecting remote access involves two elements. A temporary network connection, so depending on what kind of connection it is, it could be telnet, it could be secure shell, it could be remote desktop, it could be virtual network desktop, it could be Citrix, whatever. There has to be a temporary network connection and a series of protocols to negotiate privileges and commands. Temporary network connection can occur via a dial-up service, the internet, wireless access, or any other method for connecting to a network. Once the connection is made, the primary issue is authenticating the identity of the user and establishing proper privileges for that user. This is accomplished using a combination of protocols and the operating system on the host machine. The three steps in establishment of proper privileges are authentication, authorization, and accounting, commonly referred to simply as AAA. So authentication is the matching of the user-supplied credentials to previously stored credentials on a host machine, and it usually involves an account, username and password, or token, or something of that sort. Authorization is the granting of specific permissions based on the privileges held by that account. So let's say you have a username and account for an account and the password for it. You try to connect remotely, but that account does not have the privilege or the permission to allow remote access. Well, guess what? You're still not getting in. So authorization, you got to have authorization. And then accounting is the collection of billing and other detailed records. Network access is often a billable function, and a log of how much time, bandwidth, and file transfers or other resources are used needs to be maintained. But not only that, but you want to know who they're or what they're accessing for resources. So accounting does not necessarily have to relate directly to billing, but you want an accountability in the sense of what systems are they accessing? Are they accessing resources they have permission to access? And are they trying to access systems that they don't have resource or privileges to access? Because if they are, that's as much telling, even if they're getting rejected by that resource and being told no, if you're seeing that the person is consistently trying to access something they don't have access or permission to access, that's telling you that something's going on, something's wrong here. So in order for there to be authentication, first there has to be identification. Who are you? Who is the user that's trying to make a connection? Is the process of ascribing a computer ID to a specific user, computer, network device, or computer process. User identification enables authentication and authorization to form the basis for accountability. Authentication is the process of binding a specific ID to a specific computer connection. So two items are needed for the binding to occur: the user ID and some secret that proves that that user is the valid processor of the credentials. Historically, three categories of secrets are used to authenticate the identity of a user. It's either what the user knows, what the user has, or what the users are. Today, there's also the additional category of what the users do. But looking at what users know, that's your username and password, username and PIN, things of that sort. Something you have memorized, passphrase, or something of that sort. The security questions you have when you try to access your bank account, that's also what you know. Then what the user has, that could be, for example, a access card, a badge, one of those security tokens we looked at earlier, things of that sort. You have a physical, something you physically hold on to or virtually hold on to that distinguishes that only you should have. Think of it as the key to your door. That's something you have. And then what the users are, these are usually biometrics. So it could be retinal scans, it could be facial scans, fingerprints, anything of that sort. It's harder for somebody to replicate or to fake. So these different categories of secrets are used to authenticate. They're also sometimes known as factors of authentication. So you sometimes hear the term in security of multi-factor authentication. So single-factor authentication is just using one of these to authenticate who you are. So it's just using your password, or just using a PIN, or just using a fingerprint. Multi-factor means you have to have at least two things that combine together. So for example, in the military we use an ID card that has a chip in it, and a PIN that goes with it. So you got to know the PIN, and you have to have that card. Or in some cases, you have I told you about the token. You have to know the password for your account, and you still have to have the token and the code on that token. That's something you have and something you know. Or maybe it's a fingerprint and a PIN, or fingerprint and a password, or fingerprint along with a badge. Multi-factor authentication. And something you do, well, systems are becoming more smart and can figure out, like, for example, how you go about doing keystrokes on a keyboard and how you do it. So you might not be just the password you put in, but what is typically the speed that you put it in and how you use the keyboard to enter it in might be something you do in order to gain access as well. So we know that authentication is the process of binding an ID to a specific connection. So there's basic authentication, which is passing basically username and password straight across the network, unencrypted. There's digest authentication. In this case, it is a method used to negotiate credentials across the web. Digest authentication uses hash functions, and in order to improve upon just sending a clear text password. Digest authentication works by the client requests a login, the server responds with a challenge and provides a nonce. The client hashes the password and nonce, and then the client returns the hashed password to the server. The server requests the password from a password store. The server hashes the password and a nonce, and if both hashes match, the login is granted. The problem with both basic and digest authentication, though, is that both are passed in the clear, be it the password and username and password, or the new username and the hash are completely passed in the clear, which can be intercepted and used against you. So keep that in mind. Next is Kerberos, a network authentication protocol designed for client and server environments by MIT. The current version is 5, and it supports all major operating systems. It passes a symmetric key over a insecure network using the Needham-Schroeder symmetric key protocol. Kerberos is built around the idea of a trusted third party termed a key distribution center. which consists of two logically separated parts, an authentication server and a ticket granting server. Kerberos communicates with tickets that serve to provide the identity of the users. Two tickets are used within Kerberos. The first is the ticket granting ticket obtained from the authentication server. So once you've authenticated with the server, it sends a ticket to the ticket granting server saying, grant this person the ticket. And then the ticket granting ticket is presented to the ticket granting server when access to a server is required or a service is required, and a client-to-server ticket is issued, granting access to that specific server. Typically, both the authentication server and the ticket granting server are logically separated parts of the key distribution center. Kerberos was designed to work across the internet as an inherently insecure environment. Kerberos uses strong encryption so that a client can prove its identity to a server, and the server can in turn authenticate itself to the client. A complete Kerberos environment is referred to as a Kerberos realm. Kerberos server contains user IDs and hash passwords for all users that will have authorization to the realm. Kerberos server also has shared secret keys with every server to which it grants access tickets. In a previous chapter, we talked about digital certificates, and so it's kind of brought up here very briefly that it can be used also as a means of authentication on systems. You can use it, for example, to authenticate on a SSH secured shell connection to a Unix box if you properly configure it. Same thing with Cisco routers and switches. You can use certificates as a means of authentication for logins. Tokens is a hardware device, as we talked about, with the that changes like every minute or whatever the frequency is for your system, that provides you something that you have to have and something you have to know at the same time. And then I kind of touched on multi-factor previously in the last slide. It basically requires two different types of factors of authentication. So it could be what a user knows plus what a user has. It could be what a user knows and what users are. And it could also be two different things of what a user knows. Think about the fact when you sign into your banks, you not only have to get through with your username and password, but it might ask you an authentication question, such as your father's middle name or your mother's maiden name or your puppy dog's name or something of that sort. So two different pieces of information you might need to know can also be used to provide multi-factor authentication. Authorization, we already know, is a matter of providing people with privileges or denying them privileges and access based upon what they should or should not have. And then access control, same thing. It's not the same thing, but access control can be used to describe a variety of protection schemes. It sometimes refers to all security features used to prevent unauthorized access to a computer network or even a network resource such as a printer. In this sense, though, however, we may be confused with authentication. More properly, access is the ability of a subject, such as an individual or process running on a computer, to interact with an object, such as a file or hardware device. Once the individual has verified their identity, access control regulates what the individual can actually do on the system. Just because a person is granted entry to the system does not mean that they have the right to all the data that's there. So the next section of the book, remote access methods, I kind of don't necessarily think that it's properly named for what it discusses. So first off, it discusses IEEE 802.1x. It's an authentication standard that supports port-based authentication services between a user and an authorization device, such as an edge router. IEEE 802.1x is used by all types of networks, including Ethernet, token ring, and wireless. This standard describes methods used to authenticate a user prior to granting access to a network in the authentication server, such as using radius. The 802.1x acts through a intermediate device, such as an edge switch or an enabling device of the sort that enables ports to carry normal traffic if the connection is properly authenticated and prevents unauthorized devices from being plugged in. So That's why I don't necessarily agree with the title of the section, remote access methods, because really this is not remote. It's plugging it in directly on your network. When you would think of remote access methods, you would think of somebody dialing in or using SSH to make a secure shell connection to a Unix box or something of that sort. But in this case, that's how they describe it in this section of the book. So understand that IEEE basically it authenticates the user and the hardware before it allows the hardware to have any kind of speaking capability or network connection capability. So literally, if you try to plug in something that is not authorized or you're an unauthorized user, that computer will not be able to speak on the switch or on the device that it's plugged into. Once again, remote access for wireless protocols. In the case of where they're talking about wireless here, they're talking about 802.1x, and that requires that you have to be physically present. So I don't see it as remote access. Where it is all right here is the Radius and the TACACS servers. These are ways of authenticating people who have connected to the network, and they can be used for remote authentication as well as local authentication in this case, especially for the 802.1x. But Radius is remote authentication dial-in user service. It provides the AAA that we were just talking about, which is authentication, authorization, and accounting. Radius is designed as a connectionless protocol that uses UDP as its transport layer protocol, and connection types such as type issues such as timeouts are handled by the Radius application instead of the transport layer. The Radius client is typically a network access server, and the network access server acts as the intermediary between the authenticating client and the Radius server before it's allowed onto the network. Radius, VPN servers, and so forth can all act as network access servers, and the Radius server is a process or a daemon that runs on a Unix or Windows server machine. Communications between a Radius client and the Radius server is typically encrypted using a shared secret key that is manually configured on each side. However, the communication between the end user machine and the Radius client, the NAS or network access server, is typically not encrypted. Then there's TACACS. TACACS Plus is the current iteration of it. It stands for Terminal Access Controller System Plus. One of the fundamental design aspects is the separation of authentication, authorization, and accounting in this particular protocol. TACACS Plus uses TCP as its transport protocol, so it handles the network errors that Radius had to do off the Radius server because it was using UDP. It's similar to Radius in the sense that it is a client-server protocol, with the client typically being a network access server, NAS, and the server being a daemon process on a Unix, Linux, or Windows box. It's important to note that if the user machine, typically the PC, is not, once again, a client directly to the Radius server, but is using NAS in between, the communication between the PC and the NAS are typically not encrypted, and the authorizations are being sent in the clear. The book goes into further detail on this, and I don't want to go into too much more detail on how the two protocols work. Just understand that TACACS uses TCP, and think of the T and the T, and Radius uses UDP. So the remote access methods section of the book covers also authentication protocols. The first two it looks at are L2TP, which is layer 2 tunneling protocol, and PPTP, which is point-to-point tunneling protocols. Both operate at layer 2 of the OSI model. Tunneling is the encapsulation of one packet within another, which allows you to hide the original packet from view. From a practical perspective, assuming you're using TCP/IP, your message may pass over various networks, such as an asynchronous transfer mode or ATM network, as it moves from source to destination, and ATM protocol can neither read nor understand TCP/IP packets. So something going along there would need to be encapsulated in a proper ATM protocol packet. By encapsulating a packet as a payload in a separate protocol, it allows it to be carried across sections of a network that are different through what is called tunneling. Each end of the tunnel can be called a tunnel endpoint. The payload can be read and understood on either end. Next is the point-to-point protocol. It's a fairly old one. This goes back a long ways to dial-up for some of you. Point-to-point protocol is still widely used for establishing dialing connections, actually, over serial lines or ISDN connections. PPP has several authentication mechanisms, including PAP, CHAP, and Extensible Authentication Protocol, or EAP. These protocols are used to authenticate the peer device, not a user of the system. So PPP is a standardized internet encapsulation of IP traffic over a point-to-point link, such as a serial line, so dial-up. Think dial-up when it comes to it. AOL was probably a good example of that, or your local ISP from the 90s. The point-to-point tunneling protocol is the next step up from that. It's a network protocol that enables the secure transfer of data from a remote PC to a server by creating basically a VPN across the TCP/IP network. This remote network connection can also span publicly switched networks, such as a phone system, and is a very economical way of connecting remote dial-in users to a corporate data network. The incorporation of PPTP into Microsoft Windows product line provides a built-in secure method for remote connection using the operating system, and it has given PPTP a large marketplace footprint. Next is EAP, or Extensible Authentication Protocol. It's a universal authentication protocol that is frequently used in wireless networks and point-to-point connections. Although EAP is not limited to wireless, it can be used for wired authentication. It is most often found in wireless. CHAP, or Challenge Handshake Authentication Protocol, is used to provide authentication across a point-to-point link using PPP. In this protocol, the authentication after the link has been established is not mandatory. CHAP is designed to provide authentication periodically through the use of a challenge and response system that is sometimes described as a three-way handshake. The initial challenge is a randomly generated number. It is sent to the client. The client uses a one-way hashing function to calculate what the response should be and then sends it back. The server compares the response with what's calculated to see if it's correct. If they match, the communication continues. If they don't, the communication is often dropped. Then there's NTLM. NT LAN Manager is an authentication protocol designed by Microsoft for use with Server Message Block Protocol, or SMB. It's an authentication level network protocol primarily used for sharing files and printers in a Windows environment. NTLM has been designed as a replacement for LAN-MAN protocol, which went out, I think it was with Windows NT4. Although Microsoft has adopted the Kerberos protocol for authentication, NTLM version 2 is still used when authenticating to a server using an IP address, authenticating a server that belongs to a different Active Directory forest, or authentication to a server that doesn't belong to a domain, and no Active Directory domain exists. So if they're all work group or peer-to-peer connections, then it uses NTLM to do the authentication. Next is PAP, or Password Authentication Protocol. It includes a two-way handshake in which the username and password are sent across a link in clear text. PAP authentications do not provide any protection against playback or line sniffing, so PAP is definitely something you don't want to use unless you absolutely have no other choice. L2TP, or Layer 2 Tunneling Protocol, as we called it, is a internet standard that comes from the Layer 2 forwarding protocol. It's a Cisco initiative to address issues with PPTP. Whereas PPTP was designed around the PPP protocol and IP networks, L2TF, L2TP was designed for frame relay and other kind of networks as well. Additionally, PPTP was designed to be implemented in software on a client device. LTTP was conceived as a hardware implementation, so it can be used on routers or the sort. So it can be used to create tunnels between routers. Layer 2 transport protocol works in much the same way as PPTP, but it opens up several items for expansion. For instance, the L2TP routers can be enabled to concentrate VPN traffic over higher bandwidth lines, creating a hierarchical network of VPN traffic that can be more efficient. It can be used with IPsec and DES encryption. Provides higher levels of data security, and L2TP was designed to work with established AAA services such as Radius and TACACS to aid in user authentication, authorization, and accounting. It uses the UDP protocol. We've discussed some of the access protocols or authentication protocols. Now we're going to look at some other ways that we can do remote access. One is Telnet, which is a very unsecured protocol, but allows you command line access to systems such as Unix systems, Linux systems, even Windows. You come in at the command line level if you have a Telnet server turned on, as you should have seen in one of your previous labs. Routers and firewalls, things of that sort. It's not recommended to use Telnet anymore because the reality is that your username and password is being passed in clear. It doesn't use any encryption or any way to protect the authentication information. Next is SSH, or Secure Shell. It's very similar to Telnet. It's basically coming in at a command line level on a remote system. Once again, Unix, routers, servers, Windows even, you can set up an SSH server on. But this time it passes the credentials in an encrypted fashion, which protects them. It's recommended that Telnet be disabled on all your systems and SSH be enabled on your systems for protection and proper connection across the network. Then we look at FTP, which is file transfer protocol. There's different versions of it. There's FTPS and SFTP. And both of those are secured using SSL or TLS. Once again, if you use just FTP, your credentials are passed in the clear. Any files that you transfer, so if you're transferring, let's say, a text file or a database file with social security numbers and credit card numbers, that's all being passed in the clear. It's not secured. If you use the FTPS or SFTP, you're encrypting it and you're providing some protection for both the authentication method that's being used as well as the data that's being transferred. VPN is a virtual private network. It's basically a secured tunnel through the internet either between two routers or between a client and a remote network. More often than not, you'll see it between let's say, various branch offices of an organization, and they use it as a means of extending their network to the different branches across the internet, but make it look like it's still on the same network. Or you have somebody who's telecommuting or traveling for their work, and they use a VPN to access their network and the resources on the network as if their computer was still on that physical network. Then there's IPsec, which can be used also for tunneling between routers and making it basically extending a network across the internet. So once again, branch locations can be tunneled so they look like they're essentially on the same network. Here it uses what's known as a security association, which is a form or manner of describing the necessary and sufficient portion of the IPsec protocol in order to achieve a specific level of protection. So it'll specify what encryption algorithm should be used, and whether or not the packet should be encrypted, whether or not the header should be encrypted, and so forth. So all that is associated when there is a connection being made. They negotiate, and based upon shared criteria, they'll create that security association between each other, which is basically a secured link. I'm your instructor, Peter Keurig for Nashville Community College. Thank you for watching.